Good afternoon. Again, I'm a solutions architect for Cray supercomputer. I have a life sciences perspective on things. So we're developing this Eureka GX analytics platform and have had some user experiences with it. And also I'll talk about a few case studies at a high level. Let's move forward. So why Cray? It's the only pure play now in HPC. And we've basically been there and done that with some of the most complex technological fields, from aerospace to Wall Street. Our product roadmaps leverage deep, broad expertise in HPC, generous spans of development time, and tens of millions of dollars. Whether you're doing machine learning algorithms on our Eureka GX analytics platform, or you need serious scale to do discovery modeling, deep learning, or large-scale simulations, Cray's vision of adaptive supercomputing exploits multiple processor architectures to create a very powerful, scalable system. And a number of those systems. You want return on your investment, and many of the ROI types of analyses will go out to 3 years. We're finding our systems are lasting longer, so you can take it into the black. We're proud to support our systems in the field for the entire product life cycle and have the reputation of excellent customer support. We also thrive at the confluence of scalable supercomputing and fast big data. As your needs change, our products will meet your needs. I would also like to mention a couple things that aren't bulletized here. We have an Aries interconnect, and that's a technology that lets you see huge swaths of memory as contiguous. And the way that it does it is it guarantees no more than 2 hops between any two, if you're running Spark instances, any 2 Spark cores. The other thing I didn't list here is that we're actively working with data centers to put HPC as a service into public and private clouds. So what's compelling you? To have a superior user experience, you have to address both immediate and sustained value. Have to provide sustained value. So we have a factory integrated hardware and software that, and I'll show that in detail in the next slide, to get you up and running, and focused on the software you need to write, the app you need to deliver, the service you need to put out in the cloud. And not to worry about cluster management, IT headaches, components that don't work together or missing. So as far as sustained value, you need to be able to run end-to-end workflows, and you can do that. We provide a deep analytics ecosystem shipped with the product. We have also witnessed and experienced with customers what I call interactive scale, and that is data science is typically iterating over a workflow. So any productivity gain that you see in one iteration gets multiplied. And when you bring to bear enough computing resources, you can turn hours of delay waiting into minutes or seconds. And that's what I mean by interactive scale. So now you're really staying focused. You're keeping the squirrel focused on the nut, if you will. And that segues well into what I call accelerating community productivity, which means your people are now focused on productive software development and not waiting around. So you may have software developers, you may have subject matter experts, users, other people involved in the loop, your agile process. And you want to keep all of those people focused. So what you see is this heightened productivity, and I'll talk about that in some detail. So this is a look at this product, which allows you to fit up to 48 nodes, each with 32 cores, and either 256 gig or 512 gig per node in a single rack. So it's fairly dense compute. So I'm referring now to the left side of the diagram, which is more hardware focused. You put HDFS on the SSDs. On the right side now, we're trying to show you how we embrace open standards. So this is not a proprietary architecture by any means. It's a fairly deep ecosystem to do these end-to-end workflows. And so CentOS at the bottom, and as you go up the stack, you can see some fairly common, powerful open source projects from Apache. In the middle there, you see we have Spark, we have Hortonworks, and what we call our Cray graph engine, which allows you to do analysis, Sparkle queries on trillions of RDF triples. Of course, you have the modern programming languages above that, and then if your gig is Jupyter Notebooks, you can start there, run out of there. So this is our vision of a well-integrated, well-engineered stack. The purpose of the graphic here is not to test your eyes, but to just emphasize that there are many interdependent components that need to work seamlessly together in a real world end-to-end workflow where you're ingesting, you're analyzing, you're reporting. In many cases, the ultimate goal is to have a dashboard that an analyst can be looking at to control and optimize a process. So I will now transition into some case studies. The first FinTech case study is with a new partner of ours, Lightbend, and they're here. These are the original authors of the akka framework. And the use case basically is to spin up microservices as 1,000 VMs and compare the performance on Eureka GX to Google Cloud. And we were very excited, and so was Lightbend, to really see vast improvement on the Eureka GX platform over Google Cloud. A second use case is banking compliance, and this is large-scale graph where you could have billions or trillions of edges representing a set of regulations that a bank needs to comply with. So essentially, you're creating a living model for the bank. On the left side, you can envision this as a subscription service where that bank's regulations are codified in a model that's fed into a compliance engine. On the right side is the normal workflow of transactions in the bank, and that feeds into the compliance engine with a bank API. And Sudhir Chandra, who's another solutions architect at Cray, is here today. So if you have specific questions here, certainly feel free to reach out to him. He's down on the floor now. A third case study is with the Broad Institute. I spent the better part of last year working with researchers there, trying to help them with their best practices and workflows across different groups. So the HAIL group is doing large-scale genomic variants. GATK group is the Genome Analysis Toolkit, which is being ported to Spark. CGA is the Cancer Genome Analysis group, which does a lot of feature-based processing on disease genomes, specifically cancer. Proteomics group that's trying to automate calls in mass spectrometry, and some other groups. And what we're seeing is some of these groups can get 3x improvement, productivity gains, and some, specifically HAIL, and I'm citing some of the reference sets, 1,000 genomes, this exact set, which is human exomes, and Nomad, which is a combination of whole exome sequencing and whole genome sequencing. They're seeing, when we started with the HAIL group, they were at about 50,000 whole exomes, and now they're over 200,000. And the aim is to go greater than 1 million, so we'll be with them as they grow. These are some amazing quotes, and I want to talk about amazing from two different perspectives. One is that the amazing ways that Broad researchers are challenging the limits of science. And the second amazing is how well the platform has provided, the Eureka GX platform has performed for them and their satisfaction. So I guess, yeah, those speak for themselves. There's one other quote, or at least comment that I've had from users frequently, and that is they're able to switch between tools very easily. So they'll do their pi-hail analysis and come up with an initial look at what they think the statistically significant variants are in the set, and then they'll be able to hop over to R and maybe do some plotting and then come back. So moving between tools is very easy in this environment. I also wanted to give a shout out to Cotton Seed's talk. By show of hands, did anyone see Cotton's talk this morning? So I think it's quite an interesting, so it seems like many people have seen it, so I'll dig a little bit deeper into that. So one of the reasons Hale chose to do their own custom schema was so that they could get at metadata both from annotations, so the patient annotations on one dimension, let's say the columns, and the other dimension would be the variant annotations themselves. So these are the lower level annotations. And that technology is typically put into VCF files, variant call files, and that technology is on the move now. There's a transition away from that because it's a fairly suboptimal way to access things and index things from files. So there's a collaboration going on with Intel to do it's an open source project called TileDB, and on top of that will be layered GenomicsDB. And so there's some flux in this world, but there needs to be flux to scale up another log. To go from 100,000 up to 1 million, there's going to have to be a technology leap. So that's ongoing too. Thought I'd mention it. So benefits in summary for the Broad have been a lower total cost of ownership, and I'm speaking relative to Amazon Web Services, and I'm also assuming that you have 40% utilization or better on your cluster. So there's assumptions that go into that, but I think that they have felt some of this. They're running workflows faster, and in short, they're able to publish faster because they're able to get those algorithms coded and running faster. They are able to use their people better and develop code more efficiently. And they're able to lead collaborations, new collaborations. So thank you for your time. Again, we want you to have the opportunity to use Eureka GX. We have a partner network if you're interested and want to kick the tires. We have a booth, and I want to also give a shout out to the partners, again, that are here, Lightbend, the Akka platform runners, and also Exaptive, which does graph visualization. And then thirdly, Algebraics, which is a in-memory database. They have their own custom look at how to do pre-computing database indexes, if you will. It's probably not the exact correct terminology, but go to their booth, talk with them about it. They're here. So again, thank you for your time.